Hi, this is just a quick video about LHopitals Rule. I'm just going to explain the theory and then give you 4 examples. LHopitals Rule is useful for when you're trying to find a limit and you come up with an indeterminate form like 0 divided by 0, infinity divided by infinity. The rule says that if you've got two differentiable functions, f of x and g of x, then the limit as x approaches c of f of x divided by g of x equals the limit as x approaches c of the derivative of f of x divided by the derivative of g of x. I'm not going to show you how Mr. LHopitals developed this or how to prove it. I'm just going to show you how to use it. The 2 conditions before we go on. Obviously can't divide by 0, so the limit of g prime x as x approaches c can't be 0, which is what I've written there. And obviously if this is going to work, then this right hand limit here has to actually exist. So it has to have some finite value, or has to be plus or minus infinity. Right, I'm going to show you 4 examples now which sort of cover how to use this and some special cases. First thing we're going to do is we're going to look at quite a simple limit here, and we're going to do it without using LHopitals Rule and then with using LHopitals Rule, just to show you that it actually works. It's not really a proof, but it's kind of a verification. Okay, if we just substitute it in 1 straight away, we'd get 1 plus 3 minus 4 divided by 1 minus 1. So we get 0 over 0, which is an indeterminate form. Okay, so we can't just substitute in 1. Without LHopitals Rule, what we do would be factorize. Okay, once you factorize, you can see, oh, x minus 1, I can cancel that out. So that's the limit as x approaches 1 of x plus 4. So obviously we can just substitute in 1 now. 1 plus 4, 5. Alternatively, we could use LHopitals Rule. What you do then is the limit stays the same, so the limit as x approaches 1. But this time we got the derivative of x squared plus 3x minus 4, which is 2x plus 3, and the derivative of x minus 1, which is 1. And now we just substitute in x equals 1. So you get 2 times 1 plus 3 divided by 1, obviously 5. Same answer both ways. It works. Okay, second example. A little bit more elaborate. We've got limit as x approaches infinity of e to the x divided by 1 plus 2 e to the x. If straight away we just substitute in infinity, you'd get e to the infinity, which is infinity, and then obviously that's infinity. It's even bigger, so it's infinity as well, so you got an indeterminate form. Okay, so we've got the limit here. What we need to do is use LHopitals Rule. So derivative of e to the x is e to the x, derivative of 1 plus 2 e to the x is 2 e to the x. Obviously now the e to the x's cancel out, so you get the limit as x approaches infinity of a half. Well, there's no x's there, so obviously the answer is a half. Next example. Again, it looks a little bit elaborate here. If we just substitute in 0 straight away, the limit as x approaches 0 of 1 minus cos x divided by x squared, well, cos of 0 is 1, so 1 minus 1 is 0. So we've got 0 over 0 squared, so 0 over 0, which is indeterminate. Okay, so what we'll have to do is use the LHopitals Rule. Derivative of 1 is 0, derivative of negative cos x is positive sin x. Derivative of x squared is 2x. Okay, now if we substitute in 0, well, sine of 0 is 0, and 2 times 0 is 0, so we've got 0 over 0, still indeterminate. So what do? I walk away and go home. No, I use LHopitals Rule again. Okay, derivative of sine is cos, derivative of 2x is 2. Now when I put in 0, I get 1 divided by 2, I get a half. Okay, one more example. Now this looks quite different because this is not a quotient at the moment. But if I input this limit, and see I'm using n here rather than x, it really doesn't matter. So the limit as n approaches infinity of n times sine of pi divided by 2n. If I put in infinity, I get infinity times sine of 0. Sine of 0 is 0, so I get infinity times 0, which is indeterminate. So I'm going to have to use the LHopitals rule, but the LHopitals rule works with quotients. I don't have a quotient, so I'm going to rewrite this as a quotient. Instead of multiplying by n, I'm going to divide by 1 over n. Okay, it's kind of tricky. Now, this is just a bit of fun here, but if I substitute in infinity now, I get 0 over 0. So I haven't solved any problems, haven't done anything, but at least I've got it in a form where now I can use the LHopitals rule. Okay, the derivative of sine is cos, but this is a function of a function, so we're going to have to use the chain rule, and the derivative of pi over 2n with respect to n is negative pi over 2n squared. If you want, you could write this as pi over 2 times n to the power of negative 1, and you'll see really quickly where that comes from. And on the bottom here in the denominator, that's n to the power of negative 1, so the derivative of that is negative 1 n to the power of negative 2, which is what we've got here. Okay, if you look at this carefully, the negatives will cancel out, the 1 on n squareds will cancel out, so you're left with the limit as n approaches infinity of pi over 2 times cos pi over 2n. Okay, pi over 2 is just a constant, so we can take that outside. And now I can substitute in my limit here, so pi over 2 infinity will give you 0, so cos of 0 is 1, so it's pi over 2 times 1. Pi over 2 is the answer. Okay, so there's quite a few examples there, even though it's only 4 examples. I think it covers a lot. I found this website, Paul's Online Calculus Tutorials, really helpful, and they got a really good bit on the LHopitals rule if you want to do some extra reading. Thanks for watching, and good luck solving these problems.